An earthquake is a powerful and sudden release of energy from within the Earth, and the entire process begins with our planet's dynamic structure. The Earth's outer shell, the crust, is not a single solid piece, but is broken into massive interlocking slabs called tectonic plates. These plates are constantly in motion, drifting on the hot semi-fluid layer of the mantle beneath them. While this movement is slow, only about as fast as your fingernails grow, it is relentless. The boundaries where these plates meet are known as faults, and it is here that the stage is set for an earthquake. The plates can pull apart, collide, or most importantly for this phenomenon, slide horizontally past one another. However, this sliding is rarely smooth. The rock faces along the fault are rough and jagged, causing them to frequently get stuck together due to friction. As the rest of the plates continue to move, the trapped edges are forced to bend and deform, storing immense amounts of pent-up energy over years, decades, or even centuries. This is like slowly bending a giant stick, building up strain until it can no longer hold. The critical moment of an earthquake is the fault rupture. When the accumulated stress finally exceeds the friction locking the rocks together, the fault gives way and snaps, slipping violently and suddenly. This rupture can travel for miles along the fault line. The precise spot deep underground where this slip initiates is called the hypocenter or focus, and it is the true origin point of the earthquake. The sudden rupture releases all that stored energy in the form of powerful vibrations known as seismic waves, which radiate outward in all directions through the earth, much like ripples from a stone thrown into a pond. These waves are the direct cause of the shaking we feel. The first to arrive are the P waves or primary waves. These are compression waves that push and pull the rock in the same direction they are moving, similar to a sound wave traveling through air. They typically feel like a sudden sharp jolt. Following closely are the S waves or secondary waves. These are shear waves that shake the ground perpendicular to their path, creating a strong, rolling, side-to-side motion that is often much more forceful than the initial jolt. Finally, the slowest but most destructive waves, the surface waves, arrive. As their name implies, they travel only along the surface and move the ground in complex, undulating waves that can resemble waves on the ocean, turning firm ground into a soft, unstable jelly that is responsible for the most severe damage to buildings and infrastructure. The effects of an earthquake are measured in two key ways. The magnitude is a single number that describes the total energy released at the source of the earthquake. In contrast, intensity measures how strong the shaking was at a specific location, which can vary greatly. A powerful deep quake might be felt over a wide area but cause less damage than a smaller, shallower quake directly beneath a city. The local geology also plays a huge role. Soft water-saturated soils can dramatically amplify seismic waves, while solid bedrock tends to be more stable. Understanding this entire process, from the drifting plates to the radiating waves, is crucial for our safety. While we cannot predict exactly when an earthquake will strike, this knowledge allows us to prepare. Scientists use seismology to map fault lines and understand earthquake cycles. Engineers design buildings with features like base isolators that act as shock absorbers, allowing structures to sway with the motion rather than collapse. Furthermore, the different speeds of the seismic waves enable early warning systems. By detecting the fast, less damaging P waves, alerts can be sent out seconds or even minutes before the destructive S waves and surface waves arrive, giving people a critical moment to take protective action. In essence, the shaking ground is a powerful reminder that we live on an active planet, but by understanding the science behind it, we can learn to build, warn, and endure. Like, share, comment, and subscribe in English USA language only.